a few days ago, I came from Copenhagen, Denmark, here to Denver in order to talk to you about one part of my master thesis project, which I successfully defended at the end of August this year, and which I am currently working on extending. I claim that this project is one of the hottest research projects that anyone could work on right now, simply because it's dealing with two important topics. First of all, advanced image analysis using deep learning, which is nothing else than artificial intelligence. And second of all, it's dealing with food. We all eat, we have to eat to survive, and I hope that we all love food. So, in order to start, I have brought two quotes with me today that underline the importance that food has on our all life. So the first quote was taken from a survey paper, and it says, "Food plays an important role in defining our identity, social status, religious significance, and culture." Okay. The next quote is a little bit older, coming from no one else but Jean Anthelme Brea-Savarin. And she said, "Tell me what you eat, and I'll tell you what you are." Okay? So, let's get started. What would be the two most important situations in life in which we, as humans, fundamentally require proper dietary intake? Well, I would say that it's, first of all, during illness, when our bodies are when we are just physically weak. And second of all, as time goes by, we naturally grow old, okay? So we need to maintain our bodies, our human health, in order to survive as long as possible. And recent articles, scientific papers, have shown that malnutrition in these two situations, in which we all will eventually find ourselves in, can be a significant threat to our health, if not even to our lives. Okay? So how amazing would it be if we came up with a tool that could help us track dietary intake information, such as calories, sugar, fats, whatever you want, just name it, based on single photographs, knowing or keeping in mind that current deep learning techniques, or saying image analysis algorithms, started to significantly outperform humans in terms of single image analysis tasks. Okay? So how about we put this together into one tool, which, sorry for the misplacement of the box, it should be a little bit lower, I don't know what happened. But at my university, we combined all of this into one big project that is currently ongoing, which we call EHDI tool. It's a Danish hospital dietary intake tool. And our main hypothesis for this project is that we can estimate nutrition contents of foods based on single photographs. Okay? And since developing this entire tool for a master thesis project would have been a little bit too much, the scope of my project was only to focus on the semantic image segmentation part. So for those of you who are not familiar with image analysis, semantic image segmentation means that the network does not only give us information about what there is to see on the image, but it tells us also where it is in the image. Okay, so it does basically assign categories to each pixels in the image, so that the output is not just a single label, like duck, orange, pasta, whatsoever, but it is more of a mask where we know, okay, this is this category, this is this category, and this is this category. This is the entire process or pipeline of our project. And as I already mentioned, my part was to do semantic image segmentation in order to provide a solid basis for further analytical tasks, such as volume estimation, from which it would be more easier to estimate nutrition content information. But let's stop about the general talking and dive more into some details about what I have actually done, what I have implemented, and what results I have obtained. So in order to address the image segmentation problem, I decided to implement the Deep Lab network model, which was introduced in 2015 by Chen et al., targeting the task of semantic image segmentation. Essentially, it is a modified version of the classification network VGG16, for those of you who are familiar with deep learning in this area. And since I had not worked in any way with deep learning prior to my master thesis, and as an engineer, I wanted to know what's happening behind the scenes, okay? So I wanted to find answers to the questions, what does the network see? How does it interpret the data? How does it interpret images? And how does it make its predictions, okay? So essentially speaking, I went ahead and I opened the black box, analyzing the so-called features that networks are deriving from the input images in order to perform some computational data analysis task on them. And the features of interest that are crucial for the prediction part for this network can be found in this layer. So essentially, after having selected a certain subset of samples for each category, I extracted all feature matrices for each of the samples from this network in order to just say play around with them. And one natural hypothesis for me, yet again, I'm sorry, I don't know what was wrong. One natural hypothesis that I came up with and that I wanted to prove to be true was to say that visually keen classes or categories should also share features or features that are more or less the same, right? So if we say, okay, this kind of pasta looks very like this kind of pasta, then these two images should have a very similar set of features that the network bases its prediction on. And you will hear me talking a lot about pasta, pizza, and all of this, and this is essentially not because I'm Italian, but because the data set that I was working with was Italian. So yeah, without wanting to be too detailed right now, what I did, I went ahead and I took the feature matrices of different categories. I calculated pairwise distances between these feature matrices, which led to distance vectors. And then I found out that when these distance vectors are drawn on a 2D plane, they happen to cover a certain area, as you can see, right? And now if we compare two visually keen classes or visually highly correlated classes, it turned out that distance vectors of these share a very large intersecting area. So here I compare two visually keen pasta classes, and here I compare one of them with oranges. And you can tell that this green area has become a lot smaller. Okay, so the more not alike, I would say, two classes are, the smaller this overlapping area would be, if non-existent at all. Right? So I went one step further. I expressed this area in terms of a number. And I went a little bit more creative. I decided to apply graph theory. I took these numbers because I wanted to create this overall model which would show me the correlations between different categories expressed by means of the numbers that I derived from these graphs above. Okay, so this led to this subgraph, for instance, where these numbers taken from those graphs above were the weights on on an undirected weighted graph. And then since I was aiming to group visually highly correlated classes, I went one step further, and I decided to extract triangle meshes. Triangle meshes because of certain pre-assumptions that I made. And these are the results. Okay, so we have 2 pasta classes and 1 rice class. Looks good. And this is another big group that I derived. And of course, as humans right now, we can argue that scrambled eggs might not necessarily taste like squid or pasta with tomato sauce. But I am very much convinced that training the network more excessively, even on a larger data set, would have led to even better results than just this. So I was talking a lot about feature analysis right now, but the main goal was to do semantic segmentation, right? So what are the results that I actually managed to obtain after having implemented the deep lab model? Well, here we go. And I think this was already the last one. Yep. So I hope I was not too nerdy about something that I was very passionate for 5 months about. If any of you happen to have more questions about this, please go ahead, ask me when we're done here. I would love to answer all of them to the fullest extent possible. And other than that, thank you very much for your attention.